Hopefully this video is going to help you solidify your understanding of solving exponential equations just using your index or exponential rules. Okay, so hopefully you could do most of this without using a calculator. In order for this to be done, you need to be really upskilled and understand and remember your index laws. Okay, so hopefully you've got them under control, you've got them written down on a bit of paper somewhere. Okay, so here we go. When we're solving these, the main thing that we need to do is we need to get the same base. Okay, it's all about the base, It's pretty easy to pick the base. It's going to be most of the time it's going to be a prime number, and it's given away in the question itself, really. You can see, I mean, in this question, we've got a base of 2. So the left-hand side is pretty much done. All right, we're going to rewrite that, and that's 2 to the x plus 3. We look at the right-hand side, and lucky for us, right, we know that 32 can be expressed as 2 to the power of something. Hopefully we are aware of our bases for 2, right? 2 2s are 4, 4 2s are 8, and so on. So we've got all of this under control, and now this is like our aha moment. Because we've got the same base and they equal each other, the powers have to be the same. So this is when we now say, therefore, x plus 3 equals 5. And it's now just linear algebra. Get rid of the plus 3, take 3, bang, 2. Okay? Clearly they're going to get a little bit harder than that, but this is the basic concept. Get the same bases on either side, making them equal each other, and then the powers have to equal each other. Because some of you are probably saying, oh, I could have solved this just from looking at it. Get used to doing that process. Alright, so on to the second question. We looking at the 27, we're looking at the 9. And we want to be able to write them as the same base. So clearly, I hope it's as clear to you as it is to me, that it has to be 3. Because I can write 27 as 3 cubed, and I can write 9 as 3 squared. That's the first thing that we will do. Okay, so instead of 27, it's 3 cubed. 3 times 3 times 3. And we've still got the power of x take 1. On the right hand side, we rewrite 9 as 3 squared. And again, that's to the power. Now you've got some choices here. Okay, we've got a few things that we can do. First and foremost, we want to have it 3 to something. At the moment we've got 1 over. So what happens when we have a 1 over something, right? How do we get rid of that power? We're going to use that rule there. So if I want to move it up, I can reverse the sign. Alternatively, I can do that second, and I can say, well, I'm going to first get rid of this power to a power. And again, your exponential rules tell you that you have to multiply them. Which is the correct one to do first? Well, it doesn't matter. Let's go power to a power. Okay, just because we're in the mood for that, we're going to do the same on the right hand side. So power to a power, we have to multiply through. Don't forget to multiply the 1. Okay, and then this becomes 3 to the 4x plus 10. Once again, you're multiplying those powers up. So we're nearly there, but we want this to be upstairs. So it's going to now be 3. When we move it upstairs, everything becomes minus. So it's going to be minus 3x minus minus 3 becomes plus 3. And this is equal 3 to the 4x plus 10. You can see straight away there's no way you could have just looked at this and solved it. We've got to that point. Haha! Bases are the same. Therefore, the powers have to be the same. It's impossible for 3 to the 7 to equal 3 to the 11, right? It has to be. The bases are the same. The powers have to be the same. And now it's just a simple matter of let's solve this. So let's get rid of the plus 10. We're going to take 10. So 3 take 10 is minus 7. Get rid of the take 3x, we plus. So that becomes 7x. And I think from here we know, well, haha, x equals minus 1. Now if you're a good mathematician, you want to make sure that this is actually correct. So all we have to do is go back up to our original. We can grab our calculator. We're going to type in, right, 1 over 27 to the, let's go back and have a look, what was it? X take 1. So our x is minus 1, so we will say that's going to be minus 1 take 1, right, equals, now we're going to do the right hand side. What's that? 9, 2 to the minus 1, sorry, 9 times, 9 to the minus 2 plus 5, okay, but I'm going to type in exactly as we've said that. So 9 to the 2 times x, which is minus 1, plus 5. Oops, love that maths type. Times negative 1, oh yeah, that was right. Plus 5, okay. Yay, same answer, so we know that we're right. Remember, on your calculators, you've also got your option, calc, solve n, and we could actually type in the equation that we had. So 1 over 27 to the, forgot what it was already, x take 1. Right, use your arrow keys, get out of that, equals 9 to the 2x, was it plus 5? Yes it was, plus 5, I shouldn't doubt my memory. Close your brackets and equals. Press exit. And we get our answer is minus 1. I just find that takes too much time. I'm old school, like to sub. Okay, but please notice the steps that we go through. So make your work clear and easy to follow. All right, let's have a look at the last question. We're getting in a few surds over here, so that's nice. All right, what's the base? We can see 2. Okay, so 8. What a happy coincidence that we can write that as 2 cubed. So it's 2 cubed, x take 1, equals, now I'm not going to do the right hand side all in one step. I'm going to do it one step at a time using my index rules. So first and foremost, I know that 16 is 2 to the 4, and that's times by root 2. Again, use your index rules, and we know that the square root of something is to the half. Right, try not to jump steps, otherwise that's when you're going to get in trouble. So now what are we going to do on the left hand side? Well, we've got a power, right, to a power, so we're going to times. Why? That's what the rule says. 3x, take 3. Right hand side. At the bottom, when I'm timesing by the same base, you add the powers, but you can also see we're dividing as well. Now look, what I really want to do is go, I want to say 2 to the x, take blah blah blah, but I might make a whoopsie there. So I'm going to go slow and steady, wins the race. So downstairs, that's going to be, when I'm timesing by the same base, I add the powers. So what is 4 plus a half? Yes, you can write that as 4 and a half. I like to put that as an improper fraction. So 4 2 is 8 plus 1, so 9 over 2. So I've got 9 over 2. All right, we've got 2 to the 3, x take 3, equals, I'm dividing by the same base, so what do? We subtract the powers. Okay, if you try to do it all in one step, sometimes people might have gone minus 4 plus a half, and they've messed up with that non-minus there. So make sure one step at a time. Now we've got, therefore, 3x take 3 has to equal x minus 9 over 2. X is on one side, so to get rid of this x, we're going to take x, and we're going to pop that 3 on the other side. So we've got 3, positive 3, take 9 over 2. And finally, get rid of that times 2, divide by 2, so that now becomes minus 3 over 4. Feel free to pop that into your calculator and check that should be correct. Okay, what I want you to do is make sure that you are writing down and showing your process and your steps each time. Hope that helps.